just finished the most major hardware upgrade I have done to this Zortrax. Its original hot end, not gonna lie, really sucked. So I replaced it with a Ender 3 hot end. So my Ender 3 Pro that I've modified, I added its old hot end assembly, kind of now torn apart and spread across my bed. Anyways, I had the old hot end, and I decided to modify it by sanding down that side, if you can see, so that it would fit into the Zortrax hot end's hull. Then I screwed it down, shoved in the thermocouple and the the actual heater. So the yes, this uses a thermocouple, not a thermistor, so that is why I had to modify the hot end a little bit as well. I had to drill the hole bigger so it would fit, but I also then made a taller fan spacer, that orange part, and printed it in PGG so it wouldn't melt. And I also am going to make a newer fan shroud to be better for this hot end. But so far, this has drastically improved the performance of this printer. I'm going to try PLA on it later and see if this hot end will make it so it will actually be able to print PLA without the extruder slipping. Also, the biggest part of this upgrade is I can use standard nozzles. I no longer am forced to use these Zortrax nozzles, which have this larger, which have a larger hole on the bottom. If you look, they have a larger hole, and it's deeper. I tried putting a V6 nozzle in the Zortrax's hot end. That didn't work because V6 nozzles have a big chamfer. Like they're like cone shaped. This was just a flat until the end, which sucks. So now I no longer am forced to use these nozzles. I can use any standard V8 nozzle. Also meaning if I do convert this to clipper, I can use a CHT nozzle, or I could use steel nozzles so I could print more abrasive materials without being concerned about going through nozzles like crazy. Also, this thing's heat break works a lot better than the factory heat break on these Zortrax machines. So the machine heats up faster, and it's way cooler to the touch. So it doesn't soften the filament before it gets into the hot end, it'll only melt once it's in the hot end. Because of this better efficiency, it oozes a little tiny bit more. I'll fix that in settings later when I tune the new profile for this. Yes, I am using a file sliced in Z Suite, the proprietary software for these. I will try a Prusa Slicer Benchy in PLA later with a steel print bed. Last time I was using the normal magnetic print bed, which is flexible, too flexible, so it would come up with the layer a bit, so it would curl just because it would go over and it'd come off the print bed. So now that I'll put a spring steel sheet on this and see how well that bed will do. I'm excited to see what happens with this project. This was also the first step of the conversion to this Ender 5 board. I will be giving it a different controller. And I will first off start with this thing running Marlin, because then I could have a standalone portable unit. I might change that to Clipper or Octoprint later. We will see. I do at least want Wi-Fi printing. But this board is not a silent board, but I don't care because this thing goes in my closet. But this would let me hook up all the parts. One thing I would also need to do is design a end stop switch for this so that I don't have to rely on the bed contacts on this bed. This bed is weird. It's a perforated metal sheet. It's great when printing with rafts like that and ABS because the plastic gets in the holes and holds it down really tight. Unfortunately, the only way for me to get stuff off the bed is to grab a literal chisel and chisel it off the print bed. That works, but it's not ideal. Later I will show you the finished print, as well as I will start a print via Prusa Slicer. But yeah, I'll let you guys know about this project later on.